All right, welcome everybody. I'm going to give folks a few moments to join and then we'll go ahead and get started. Okay, great. Looks like we've got a good amount of people jumping in the room already. So thank you to everyone for joining us today. Super excited to be bringing you today's presentation, Thermally Modified Wood as a Sustainable and Biophilic Product Choice for Designers. It's presented today by Lisa from the Maximo Group. Super excited to bring this presentation. I think we've done it 1 or 2 times before and it's always been a hit. So get ready for some really great information today. Before we jump into the CEU approved portion of today's webinar, I'm going to give a quick introduction, show you guys some helpful resources for after today's event if you're looking to get some more information about some of the solutions that we're going to be kind of going over today. All right, so let me share my screen here. Awesome. So all of you who signed up for today's webinar have Acelab accounts made for you. They're free to access. We've got a ton of great resources here. I'm not going to walk through everything right now, but I will share a colleague's meeting link in the chat momentarily. So if you're interested in learning some more about our platform, you can sign up for a free 15-minute demo, get to know, the resources on our platform, get some help from our team in getting yourself all onboarded and set up. Today, what I want to show you is just a few quick things. So first, the homepage is a great place to come for our next upcoming webinars. You can always sign up for them right through here. But what I want to show you is just how to get in touch with Lisa and how to learn some more about Maximo, learn some more about thermally modified wood if you're interested in popping into some of these resources after today's event. So you can always use the search bar at the top to search for products, for brands, for other resources. That'll auto-populate and just make sure you're toggled on the right tab here. Then you can head over to a brand page on Acelab. From here, you can contact Lisa directly. So if you've got some questions that come up after today's event, you want to connect with her about a project, this is a great place to come, get in touch with her directly. You'll get a conversation on your Acelab account. You'll also get an email that you can reply to, and I'll show you where those conversations live in a moment. Scrolling down here, you can view some more about the company overall, their main value propositions, and then explore their products. You can save these to either your library or to one of your projects for future reference. And you can also open up any one of these product pages and view some more product information, get some information about dimensions, performance data, access downloads. So this is a really great place to come after today's event if you're looking to get some more information. Last thing I want to show you today on our platform is just if you do end up getting in touch with Lisa, you can either do that through our platform directly. You can also let us know during today's webinar and we'll go ahead and connect you. Those conversations live up here over by all of your other account stuff. Just click this little icon on the right here. And that'll bring you to an overview of all the conversations that you have on Acelab. So again, you're going to receive an email anytime you've got a new message. You can respond directly to those emails, so you don't have to open this platform to be able to communicate. But it's a really great place to keep all of your communication with reps organized in one place, along with your product research and product data. So just wanted to show you guys this quickly today. Again, I'll send my colleagues meeting links. So if you're interested in learning some more about how this all works, please feel free to sign up for a demo with our team. We're happy to help you get set up. All right, last thing I want to mention before we jump into the CEU portion, this is an AIA-approved event. We did ask for AIA numbers upon registration. We'll also send over a form in the chat in a moment so that you can submit your AIA number as well as a certificate request there in case you're worried that you didn't do that already. Last thing is I just want to really encourage everyone to ask questions throughout today's webinar. We'll be keeping an eye on those. We should have some time to get to some questions live. And if we don't get to your question live today, we'll have a record of that so you can be followed up with after today's event. All right, that's it for me for now. Lisa, whenever you're ready, feel free to go ahead and take it away.
All right, perfect. Hello, everyone. I am going to share and put my let me see. Sorry about that, guys. Is it working yet, Bo? Sorry.
No, all good. Not quite yet. I think you need to click the green share button and then just select the screen that you want to share.
Okay. I can do this. I apologize for that.
All good. Looks like it's loading up now.
Okay, perfect. Okay. Welcome everyone, and thank you very much for taking time out of your busy schedules, especially as we approach the holidays. I know things get busier, but really appreciate everyone being here today to learn a little bit more about thermally modified wood. Again, as Bo mentioned, I am Lisa Ayala and very happy to connect after the presentation with any additional questions you may have that we don't get to today. But what we will do is go through this, as Bo had mentioned. The provider number, the course numbers, so you do get one learning unit HSW credit for this presentation. Also, for anybody who self-reports to GBCI, this is approved for 1 CE hour in that as well. So what we're really going to do, I'll go through the learning objectives, because the course description is really learning all about thermally modified wood, really sort of getting a basis on it, the history, where did it start, where has it been, where is it going? So we'll kind of go through, past, present, future kind of information. I'm going to talk a little bit about the wood species that are used for this type of thermally modified process, the techniques. We'll go through manufacturing, and I go through all of this so that you have a good and clear understanding of this process, because there are other processes out in the market. So just so that you have familiarity with this particular type. Then we'll go through a section on the environmental benefits, and not least deserving of comment is also the biophilic benefits of using thermally modified woods. Finally, we'll go through some projects that have been using thermally modified wood on a global basis. I've got some in the US, some in Scandinavia, and so I'll share some global projects to also show that the wood and this wood can be used in all sorts of climates. And then we'll go through some best practices, and then hopefully some Q&A. So with that, what is wood modification? Wood modification is taking wood, putting it through either an autoclave or a kiln, some sort of reactor, if you will, and changing the structure of the wood at the cellular level, at the molecular level, and basically wood modification is very different from wood treatment insofar as wood modification does literally change the wood at the very core level, or the cell level, or the molecular level, whereas a wood treatment basically takes wood and will surface treat it around the edges, and then the inside of the wood is not protected or changed. Modification is a permanent change. So there are 3 types on the market. There's chemical, there's biological, and there's physical changes where you can add something into the wood and cure it. Biological would be thermally modified wood, and chemically modified wood is where you're inserting a chemical of some sort that will change the wood through heat also. So today, what we're really spending our time today about is the thermally modified process, which is, by the way, just to back up, I have experience in all levels of modification. So I've been through the chemical processes, I've been through the physical resin impregnation type processes, and certainly the thermally modified. I love the thermally modified type process because it is really using just heat and steam. So that's it. And we'll get into that a little bit more, but no preservatives or no toxins. So again, as I mentioned, you can see the 3 types on the marketplace. You probably may know some of the other types, but our basis today will all be about thermally modified wood. So a lot of people, and when I'm in person, it's obviously easier to do this because I can have a show of hands who has heard of thermally modified wood, and who may not have heard of it. I do, just a poll, if you will. And what's been interesting to me is that over the last, 10 years, 10 years ago, you'd get maybe 10 people out of, 100, you'd get 10% saying that they had heard of thermally modified wood. That number is now, today, I get about 70% to sometimes 80%. So most people have heard of thermally modified wood. It has been around for forever. from an educational standpoint, it was actually studied in the early 1900s. And Callum Hill, who is a wood scientist out of Bangor University in Wales, actually found the first documented paper on thermal modification appeared right here in the US at the Forest Products Laboratory in Madison. So the Forest Products Laboratory works really heavily with the University of Wisconsin, and also obviously they're a part of the USDA and the US Forest Service. So it's interesting that this process has been studied since 1911. Other modifications, some of the chemical modifications came on a little bit later in the 1930s and 40s. But so people ask, well, Lisa, you know, it's now 2024, and you know, why are we really kind of just now hearing about this? Why haven't we heard about it before? Well, it took a lot of years of research and development, number one. And number two, there's always been the feeling there's been an abundance of old growth trees. There's been an abundance of tropical hardwoods that we can, you know, constantly harvest. And as we come into the 2000s, we find that, you know, this actually wasn't so true. And I'll back up, it really was in the 80s and 90s. We started really looking at forestry practices and, you know, some of the old growth trees that take 50, 60, 100 years to really grow to harvest. It was looking like it wasn't becoming very sustainable. So this process works because you can use trees from very fast growing tree sources and very well managed plantation forests. So that's why you're hearing about it more now, because we are trying to use different options than just continually cutting down forests. So with this, I'm going to give you a little video that certainly the speaker's voice is probably more pleasant than mine, but it will give you a quick synopsis, a 2-minute synopsis, and then we'll go through it a little bit more.
Like all things natural, simplicity is key. That's what makes thermal wood so special. Despite all the science behind it, we keep it straightforward and organic, just as Mother Nature intended. Let's explore what goes into making thermal wood in 3 simple steps. Our journey begins with meticulously selected timber, ushered into a specialized kiln designed for the thermal wood process. Unlike unoriginal procedures that use autoclave methods, this patented process utilizes precise heat to expel moisture from the wood, safeguarded by steam in an oxygen-free environment to prevent any risk of cracking or burning. At this stage, the wood's moisture content approaches 0. Next, a controlled, consistent temperature fosters pivotal chemical and physical transformations. This authentic method not only eliminates substances that make the materials attractive to fungi and insects, but also bestows the wood with a deep, rich, characteristic hue, revered by architects and designers worldwide. Following the high temperature treatment, gentle steam initiates cooling to precisely adjust the wood's moisture content to 4 to 7%. This reconditions the wood, safeguarding against brittleness, an advantage over unpatented methods. Embracing an eco-conscious ethos, our chemical-free process uses heat and steam alone to enhance wood, making it stable and durable for a wide array of applications, indoors and out, from walls and ceilings to decking and beyond. That's how we take a timeless natural resource and transform it into an exceptional building material that will last for generations to come.
Okay, so I think that gives a clear picture. It's, you know, really it's not a difficult process, other than that you have to have really good kilning skills, I would say, to be able to do this type of process. So as she mentioned in the video, it's really a 3-step process, and I just want to make sure that the screen can be seen by everybody. Sometimes after I come back from a video, it doesn't show. I just want to make sure. Are you able to see the screen again?
Yes, yeah, looks
Okay,
good to me.
thank you, Bo. I just wanted to make sure on that. So really, it's 3 steps. Step 1, let me just actually show this chart. I kind of, gives a better indication. You're taking wood, you're stacking and stickering it, you're putting it in a kiln. The kiln is then heated to various temperatures just based on either whatever the wood species is, and sometimes the thickness or the width of the wood will also determine that. But either way, the temperature can go anywhere from 100 to 212 in this doesn't show it, but some species actually go up to 230 degrees Celsius. So what they're trying to achieve in phase 1 is to bring that moisture level. All wood typically comes in around 15 to 20% moisture content. So what they're trying to do is heat the wood so that they can start lowering the moisture level within the wood. When that is achieved, you're hitting phase 2 now. When the desired temperature is achieved and you get the moisture level within the wood down to 0, that's where all the sort of science and magic, if you will, occurs at the cellular level. So you're taking the wood, your extractives and a lot of the resins, tannins are removed from the wood, and these are the things that attract microorganisms and in some cases some insects. And then once that sits for a couple of hours, then it goes back to lowering the temperature and bringing the moisture level up to a 4 to 7% moisture content. So that is what you will finish out with. And during this phase, that's when steam and water are introduced into the kiln as it's being lowered. So you're conditioning the wood back so it won't be extremely brittle. You have to have some moisture in wood. So when we talk about the factories are very meticulous, they are really under the guise of the International Thermowood Association. So the International Thermowood Association was started in 2000, so some 25 years ago almost. And those people that adhere to these standards will also adhere to very well-kept factories. It's very important that wood comes in its rough sawn state prior to going through this process, that all the wood is checked for sort of defects and that kind of thing, so that once it goes into the kiln and is gone through the process, you'll have good acceptable boards coming out of the process. So I think I'll just show, this is 10 seconds. It's very quickly. It shows, you see how light the wood is. And this is it getting ready to go into the kiln. And you'll see the difference when it comes out of the kiln. So you can see what happens during the process, because it is the wood is heating up to quite excessive temperatures. It does tend to sort of turn the wood a very nice honey brown color. And we'll talk about what happens to wood out in the environment in a minute. So a lot of you may be asking, okay, this is great. What is the future for thermally modified wood? Where are we going with it? We now know we have certain applications such as decking and cladding and soffits, but what about the future? Well, I challenge everybody to look to CLT, to look to mass timber, because thermally modified wood can be very, very promising for this type of application as well. And I note that there are a lot of CLT type buildings that are going up now throughout. And what I did here was take a photo of the CLT hybrid wood building in Milwaukee, Wisconsin, that is basically, I think has the designation currently of the tallest CLT hybrid building at 25 stories. What I'm being told is that it there are others in the works right now that will surpass this, but not to fear. I think, there are other buildings in Wisconsin and I think out in Oregon, I hear that will continue to make these advancements. So I encourage everybody to think about CLT and where the future is going in mass timber and the use of thermally modified wood as that application. When we talk about wood sourcing, there are several species, at least within this, within what I'm discussing, that are used for thermally modified wood. What we'll talk about today are AIAs, which is a natural hardwood. It is a very nice yellowish brownish tone, which the process does darken a little bit. It takes the process. Typically, we see that softwoods take the process a lot better than hardwoods. But in this case, this particular hardwood works really well with the process. So there are different things that AIA is great for. And if you could hold on one second, I apologize. My dog is going crazy. I'm sorry.
Thanks for your patience, everyone. Oh, you're back?
Yes, I'm sorry. I think
Oh,
I
that's okay.
got him under control. I tried to leave him in a different room, but today he wasn't having it. So I thought, well, he'll be calm. So please forgive me, everyone.
All good, all good.
Okay.
Thanks, everyone. All right.
Thank
Go
you.
ahead, Lisa.
Okay, so where I was going with the AIAs is that it's easily machinable. It is a hardwood, but it's a really soft hardwood. What we find it is best for are things like soffits, ceilings, and certainly interior use. I would not use AIAs for decking, certainly not. It is too soft for decking. And in some cases, I would not use it for full siding, but I might use it for accent walls, exterior, but certainly interior works really well. Then moving on to the other species that we use very readily is ash. And ash is hardwood. So this likewise takes the process really well. And it has a nice light medium brown color. And because of its hardness and density, it can be suitable for things like decking and even furniture benches we've seen. It likewise has a very nice machining capability. So it's another really good species that takes you to, different applications that you'd be able to use for it. Scandinavian species it's probably my favorite, only because those beautiful butterfly character knots that you see there. It is a softwood. It is a Scots pine, and as the name indicates, it's mostly found in the Scandinavian countries. And it is a really nice rustic look to it. It basically can be used for siding, ceilings. It likewise can be used for interior type. We put decking here, but the Europeans will use the Scandinavian species for decking, but in the US, I have found that we prefer not to use this as a deck product. But we can talk about that should you have any questions with regard to this species. And last but not least is radiata pine. So we call it our radiata clear because it basically is the fastest growing plantation tree that I know of. It originates from New Zealand, but a funny story, this is actually a sister to Monterey pine, which is based out of Monterey, California. And years and years ago, they took a lot of saplings from the Monterey pine and started planting them in very lush areas of New Zealand, Chile. There are other areas of the world that are now growing this. But because this tree tends to grow so fast and they start pruning it at the very early stages, they really get a very straight and almost defect-free log and tree wood, if you will. So with the radiata, with the thermal modification on it, again, wonderful species for cladding, all of the things that we've mentioned before. This as well, if at a 1 inch thick, I would not put a 3/4 inch thick deck with radiata, but certainly a 1 inch thick deck I would use with radiata. But because of its performance, it really is a special wood to use throughout all sorts of applications. When we talk about the benefits of thermally modified wood and why use thermally modified wood, there's a lot, but I have put 6 because of time constraints, so I'll only go through 6 here. But certainly the top 2 are dimensional stability and durability. So again, if this were a live class and I were able to see everyone, I would ask the question, do you design with wood? And, you know, unfortunately, I get a lot, it is increasing. I get a lot more positive, higher percentage now, answering in the positive now. But I've always asked, well, you know, I guess your fear in designing and using wood, especially on an exterior application, is the fact that you may say, well, I don't want it to cup and bow, or I've had wood projects that have rotted on me and the replacement costs are too excessive. Well, if I told you that you've got a wood product within all the species, any species that you chose to use outside, a 20-year warranty against rot and decay, maybe that would change your mind a little about using this, because what we have found is that the dimensional stability being the first, and it certainly durability and stability actually go together. But one of the biggest benefits is the dimensional stability. So when I showed you the video, how it goes through the process and the heat is risen and then the moisture content to the wood is brought to 0, the science behind that, what happens when the moisture content is brought to 0 is the cell structure completely changes. So within wood, the cell wall of wood, you have 3 main components, and that is lignin, hemicellulose, and cellulose. So when we look back on that slide that showed phase 2, where the moisture content was 0, what happens at that point is the hemicellulose is effectively disintegrated or evaporated off the cell wall. Now, what is hemicellulose and what is cellulose? They're basically the carbohydrates in the wood. They are the things that will change the wood structure to move. They will also attract microorganisms. So when you effectively remove that, you change the ability of the wood to be attacked by microorganisms or to move. So what that means, even with different climate changes, so let's say you're in, well, I'm in Texas, so you're in Houston area that gets very humid, and you're getting wood brought in from, you know, maybe it's coming in from the East Coast where it's a little less humid and less hot. You just need the wood to sit a day or 2 to acclimate to the Houston climate, and off you go. You can install it. You won't have the sort of contraction and expansion that you get with unmodified wood. And so what that means in the marketplace is that you have less warping and cupping. So less, certainly, replacement costs and maintenance costs. The durability, again, mentioning the hemicellulose and the cellulose, when those were effectively removed, the microorganisms that will typically attack wood are not attracted to it any longer because their food source has been taken away. So again, the durability, you've got a longer lifespan, 25+ years on this. And however, there is a 20-year warranty against the rot and decay. So again, this is something I encourage everybody to think about. You've got a wood product that is not moving as much. You've got a wood product that is much more durable and longer lasting, and a warranty behind it. Moisture resistance, as we mentioned before, with the components, the lignin, the hemicellulose, and cellulose changing within the cell structure, Moisture is no longer attracted to the wood, and moisture, as we all know, is the enemy of wood. When moisture gets into wood, it will do all sorts of things, from making it expand and contract to start degrading it from the inside out. So that's when you get cracking and checking and that kind of thing. The moisture, the cell wall is less permeable. So I like to show this photo of a nice winter day with a lot of snow. And you don't have to be concerned about the wood having any reaction to all that moisture. In some species, and I will say it is the clear radiata only from the 4 that I showed you. There is additional treatment that can be applied to the radiata, which would be factory applied. And what we have found is that it meets a Class B on the ASTM E84. And we're working right now with CAL FIRE to meet the WUI standards set by the state of California. And for those that are not familiar with WUI, that aren't in California or out west, it basically is a standard where when you're developing office and home space in an area that has a lot of wildland vegetation, you have to be very careful about the spread of wildfires and that. So we are working with WUI. Please stay tuned. We hope to have some answers in Q1 of 2025 on this. Termite resistance. Thermally modified wood termites will attack anything, and especially the Formosan termite, which is one of the most aggressive termites out there. We have shown where that Formosan termite will eat through concrete really to get to wood. So they're very aggressive. They will attack anything. They will attack thermally modified wood. However, again, there is on the radiata, we are working on a water-based treatment that will help keep insect attack at bay. So please, again, if you'll bear with us on Q1, we should have additional information on that. But I would say that for the most part, termites, they go after the cellulose and hemicellulose. With that sort of being evaporated out of the wood, they tend to move away. They will attack thermally modified wood, but they tend to move away. So on the environmental, this is where we come to the part of the presentation that I really, really love. I just think thermally modified wood, it screams sustainability. It screams biophilic properties, just because it is wood and steam that have created this product. So all the wood is sustainably sourced. So it doesn't matter if it's the AUs to the radiata, they are all coming from forests that are being monitored by either FSC or PEFC. And so, you know, we make sure that anything that we purchase is falling under those credentials. The process itself, again, is a very organic manufacturing process. When you're talking about no chemicals, no need for big tanks of chemicals throughout the plant, and when you're talking just using heat and steam, it really is a great opportunity of reducing, in that part of the process, our environmental footprint. And then the other big thing to using thermally modified wood is the carbon sequestration. So many of you may know this, but trees actually serve a really valuable purpose insofar as that they suck in CO2 and they breathe out oxygen. The younger the tree, the more CO2 it sucks in. And so when you're talking, for instance, the radiata clear, it's a 28-year from sapling to sawmill harvest. It's a very quick growing tree. It has stored 50% of its weight in carbon by the time it's ready to be used into a productive piece of siding or decking. So again, with storing that carbon, we know that that product is going to be in a service life at least 25 years. you've got 25 years of stored carbon in the thermally modified wood. And then with regard to end of life sustainability, it can be easily repurposed, it can be reused, it can be recycled. Again, you're not putting anything into the earth that's not already naturally occurring there. So when we talk about the environmental and the biophilic credentials, as I just was talking about, material selection contributes very, very heavily to the environmental credentials by checking out that we are getting sustainably sourced woods. But also when we talk about the carbon sequestration portion of this, I have, and Bo, I did this for you. I have a photo of the Liberty Bell right there in Philadelphia.
Thank you.
You're so welcome. I love to show this photo. These gents are working on this, very meticulously to make some improvements. But if you notice the yoke, what's holding the Liberty Bell, that is American elm. That is the original yoke that was used in the 1770s to hold the Liberty Bell. The reason I show this is we talk about sequestration and we talk about wood and its purpose. Well, look at this piece of American elm hardwood for over 200 and some odd years that it's been sequestering carbon. So I took this from the Penn State Extension article because, the point that they were trying to make again is that trees really can and do serve a great purpose for helping mitigate CO2 in the atmosphere. With regard to biophilic design is something that you're hearing more and more about this. And the term biophilia, I think, came from Edward O. Wilson. He was talking about it in the 70s and 80s. I believe he even wrote a book. Stephen Keller, a professor at Yale University, took it one step further and said, well, just beyond biophilia, let's talk about biophilic design. So he kind of is known as the father of biophilic design. And what he basically said is, look, why don't we start designing our residences and our commercial buildings and our multifamily places to interact with nature a little bit more, because it is proven that it promotes more productivity, creativity, and health. So this building photo here that I have is one of the buildings at Yale University that was dedicated to Stephen Keller. And as you can see, the use of light, the use of wood, all of those contribute to a great biophilic design product there. And so I've used a couple of quotes from people I've known in the industry and met years ago. Rick Fedrizzi, who was the former CEO and a founding chairman of USGBC, basically has said years ago, it is about the aesthetics. Yes, we know the client wants the aesthetics, obviously, but it also is and becomes about the purpose and the why this design. And I think clients are becoming more in tune with that as well. They're saying and coming and saying, I do want, a beautiful look, but I want something to help me also feel like I'm a part of nature, because, we're now spending 90% of our time indoors. I saw a study a couple of weeks ago and it blew my mind. So I think that's a large part why we're seeing a lot of this come to fruition now. But Rick's insight into the why this design, I think, is really important for us. So the key principles, there are more, but I just chose for this, again, for time constraints and purposes of this course, the three that I think really tie in very well with thermally modified wood, and that's nature integration, prospect and refuge, and multisensory experience. So when we talk about nature integration, what better way to incorporate nature into our space than by using wood? I mean, wood is the world's most natural, renewable resource. And if you can use wood in a setting that is either A, close to the home. Maybe it's an office space that also extends into an exterior type employee kind of, regenerate space area, or a residence where it's in the kitchen, but your kitchen opens up to, a nice outdoor space. Well, what better product to use but wood? To me, wood is biophilic design, period. So I love the use of wood, obviously, in this particular photo. And obviously the other things that are integrated in is the use of light, and you can see plants. That's what most people think of when they think of biophilia, is the use of plants indoor, but it goes well beyond that. So prospect and refuge. And I certainly think that, what we all experienced back in 2020 with the global pandemic, where we really were seeking refuge. We had to seek refuge in some ways. What better way to have a space that is sort of recreating nature indoors, to make you feel that you're still able to connect with outdoors, but still stay safe and stay within your area. So the other component to thermally modified wood being used in this type of environment is the indoor environment quality. There are no VOCs leaching. There's nothing coming from the wood that's harmful for indoor air quality. So that's another reason I really think this is, such a great opportunity to use this type of product for when you're designing for spaces, indoors and out. With multisensory experience, we know that that it's very important to connect with nature, especially with children. And so when you're talking about your sensory and your use of sight and sound and smell and touch, again, what better product than a thermally modified wood product to be used on the interior of a building, so that you do have all those senses sort of, ingrained with what's going on in the environment. You see the beauty of the wood. I will say, and again, if we were in person, I would pass out the thermally modified wood, but it smells very nice. It smells like wood. It's comforting. And it also is has really wonderful acoustic properties. So this particular shot that I'm showing here is of an indoor school with young children playing, and you can see the use of all the wood that they've used here. Full disclosure, this is not thermally modified wood that I'm talking about today, but I did want to show this particular project to drive home the point about the use of thermally modified wood and wood on an interior space, especially for children. There have been so many tests, most recently out of Colorado, but I know in Japan there were several tests done on the productivity and the creativity and the attention span of not even just children, but us adults as well. And by using more biophilic design principles, it's been proven out that productivity, attention spans of children, test scores, all are improving and have been improved. This is something else I like to bring this up because it talks about the health and our mental health, our physical health, and what it having a space that has a lot of wood or biophilic type principles designed into it. I don't know, many of you may know Criswell Davis. He was a friend of mine, a dear friend who was a hardwood expert, but he also lectured on biophilic design and did a TEDx talk in 2019. Anybody who is interested, I'm happy to send you the link. But I am going to carry on his legacy about speaking about biophilic design and the importance of it. Criswell had unfortunately had gotten cancer, and in 2013, and he was going to usual hospitals with the very sterile white walls and stainless steel type interiors. and for his treatments. And he told me, it's not good either way you look at it. He goes, but I just get even more down when I go to this space. He had to change hospitals. He went to a different one that actually had started incorporating biophilic design principles in the areas where they were giving the treatments. And I remember readily he would come out and say, I feel more energized, I feel more positive. And he beat the cancer. He beat it. He said that, he just felt more relaxed. It just helped being in that space and environment. Unfortunately, in 2022, we lost Criswell to something unrelated. So I do want to pass on and continue to remind people and that this is something that is very crucial and helpful in our health as well. So, that's just a story I like to pass on in memory of Criswell. So as I've gone through the benefits of biophilic design, I think, we all know it's the health and well-being, it's the sustainability, obviously the productivity and creativity, and then it does bring us together in social bonds when, we're in outdoor spaces that tend to have, more natural product and environment. So what about the applications, you may be asking? And we talked and covered some of those already. We looked at cladding and siding. This is that beautiful Scandinavian on the side, as you can see, of home. I believe this is one of the Scandinavian homes that I was speaking of. And I love this because this is the ash, and they are using this in a tiny home production facility. So they're actually using ash on the exterior of this tiny home. I love that. And then you can just see, I'll go through these are just ideas. I'm just giving ideas out here. So you've got some nice rain screen. Again, look at that beautiful Scandinavian with that good looking characteristic butterfly knot. That we're finding it's getting more and more spec'd for areas like Colorado. Near where I'm at, there's an area in Oklahoma and Arkansas that are building a lot of Airbnbs that are, very, very much in love with this wood. And then just showing some more there. This I took, we got an up close as we could photo of this, showing that because the wood's so stable, it's one of our up there with durability and stability. This architect wanted to join it at a 45-degree miter joint and not hide it with any sort of trim, outside trim or anything. And you can see he was comfortable to do that because the wood really is so stable, it's not going to move. And then there's another school with using, that's the clear radiata with a color on it, excuse me. Soffits and ceilings. Now this is where the A use comes into play. This is such a great use for this product. And we have restaurants that are looking at putting the A use on the interior and the exterior. So it just has a, when they have outdoor seating, just has a nice flow to it. In decking, we've got some of the ash that we're showing. I think that might be the radiata. But so commercial, and you can see all sorts of, and then the interior. So when we talk about interior, again, thermally modified wood is great for this because there's nothing leaching out in it. I love that look. It's really a good looking room there. And then other uses. So think outside the box. We actually have a garage door maker who is now using wood in some of his designs or some of his projects. Fencing, I love that look. And front doors. So really, your imagination can take you anywhere with thermally modified wood on the interior and exterior. So when we talk about best practices, I do want to say, and that a lot of this would go for the contractors, when they get the wood in, please keep it under cover. It does not need to be like a controlled climate room or anything with closed doors, even if it's just under any sort of space, to just keep the environmental elements and the UV elements until it's ready to be installed. It just helps keep the wood ready. Thermally modified woods are easy to work with, but as I showed in the beginning, you've got a 4 to 7% moisture content, so it can be a little brittle. I always suggest that contractors have their tools very sharpened for this. Obviously for the harder woods, the ash and a little bit the radiata, the Scandinavian and the AIA actually can be installed using brad nails. So it's just a nailing installation. And the use of fasteners. So I do say stainless steel fasteners should be used, especially toward the coastal areas. You've got a wood product that is not absorbing moisture, but fasteners can corrode, and if they're not stainless steel and or plated somehow, those that do sort of, I think the galvanized in that, it's not the wood that's gonna be in trouble, it's gonna be the fastener, and then it'll cause, you know, ugly corrosion marks on the wood. So I always just say, look, for this wood, I would use stainless steel. On the harder woods, it is better to pre-drill, like the ash and the radiata. And also, there's a lot of clip systems out there nowadays, and we find that most of those work as well. So when we talk about finishing, that's also another big question I always get is, what do I finish with? Do I even have to finish? The answer is no, you do not have to finish any one of those species that I showed. Wood, and it doesn't matter if it's modified wood, treated wood, or modified and untreated wood, out in the environment, because of moisture and UV exposure, wood will eventually turn gray. What we found is that thermally modified wood turns a nice silver patina look. So some people like that look and say, look, I'm not going to put anything on my wood, and I'm just going to let it gray out naturally over time. And that you know, is what they decide to do, so they don't have really any maintenance. If you choose to maintain it and you want to put a color on it, I would suggest penetrating oils. There are water-based coatings that work as well, but some of the penetrating oils in the marketplace that you can get and have color put into it work really, really well. So oh, let's see. Got something. Sorry. Oh. Yep. Let me go to, I think that was it. So I just want to thank everybody very much for their time today. I encourage you to take a look at thermally modified wood in some of your projects. Again, because it's sustainable, it's durable, it's dimensionally stable. And I feel like it does elevate the quality of our built environment. And I want to continue to contribute to this, you know, for my kids, my grandkids, and so on down the line. But again, I want to thank everyone very much for your time. Today, I think I've got a last page that I can go to that I just got out of. Sorry, guys. That, you know, just there's my email, but I think you already have that, Bo. I think you've got my email and everything. So I'll just go back to the home page and I'll open it up if there are any questions.
All right, awesome. Thank you so much, Lisa. There
You're
are
welcome.
quite a few questions. So we'll see if we can get through some with our last few moments here. And then if we don't get to your question today, we will have a record of it and we can follow up with you after today's event.
Okay, fantastic.
All right. Let's see. Can we start off with, does this product dull saw blades more quickly?
Does it, I'm sorry?
Does the product dull saw blades more quickly? So I guess, does it like wear through a blade of a saw more quickly?
Oh, sorry. I am so sorry. No, so no, because it is not hard like some of the tropical hardwoods. But again, just because it can be a little more brittle because of the moisture content being low, I would certainly try to keep knives and saw blades sharpened as much as possible.
Awesome. All right. See, just gonna take care. I'm seeing a few people asking about the AIA credits. So there's a form in the chat where you can submit your AIA number as well as request a certificate. Those are going to be processed by the Maximo team. Please allow like a few days for credits to show up in your account. And yeah, then you should be all set there. Okay. Great. Next up, could you use the interior product in a wet location such as shower stalls?
That's a great question. I know we've used it in saunas, but so may I get back? May I have whoever asked that question? May I please get an email from you? Because I don't think we've ever used it in shower stalls. I do know it has been used in saunas, but I don't know the answer, and I would love to be able to find that out. That's a new one for me.
Yeah, totally. We've got your email recorded, Richard, so you should be all set. We can follow up after.
Okay.
All right. Is there any difference from a workability standpoint of working with thermally treated wood?
No, I think it glues very nice. Your typical polyurethane type glues work really well with it. Some of the like a Type Bond 3 works better than a Type Bond 2. So Type Bond 3 is more water resistant, whereas Type Bond 2 is waterproof. So I would look at that. As far as fasteners, I still say use on the AUs you can use brad nailers, and I would still say use stainless steel nails on that. And I bring AUs up because it is really soft. It is the softest of the 4 woods that I went through. But the others I would use stainless steel. As far as machining, you really don't have to slow your machine. It probably runs through your machines, or it would run through machines like probably like a Western red cedar. So you don't really have to slow your run rate down very much. They're not too dense. So if that's helpful.
All right, great. Let's see. Question, how do I source these products?
So dependent upon where you're located, I can give you some dealer information. And again, anyone who's interested in sourcing it, just because I don't know where in the country I may be talking to, there's just different dealers around. There are a number of Lumber Plus locations in Florida that carry it. There's Lumber Plus locations in New York, Massachusetts, New Hampshire, and Houston. So Lumber Plus is one, but they're sort of mostly east now. But then West Coast, I can get you the names of dealers.
Awesome. All right, great. Let's see, we've got about 2 more minutes, so I think we can squeeze one in. For curved forms, wood members can be steamed to achieve a desired profile. Has Maximo worked on any projects where steam bent wood is thermally modified?
So taking the thermally modified wood and steam bending it, I think that they did try that for an application. And again, I may need to source my colleague who was in on this project, but I think what they wound up doing, they wound up having to cut and glue to make the curve because the wood, and I don't even remember which species, I apologize. I think it was too brittle for the steam bending, or the radius, it was very, wasn't a very deep radius. But I can check on that for you. But I think there's an issue just because it is such a low moisture content. Oh, Oh, Bo, I
There we
think I'll.
go. Sorry. Looks like we are just at time. So I know there are a few questions that are still in the chat. We'll have a record of those that'll be provided to Lisa so she can follow up with anybody who maybe has an outstanding question. If you've got any other questions that are coming up as you leave today's webinar, feel free to leave those in the post-event survey. That'll pop up on your screen as you're heading out. Before we jump off, make sure you open the chat, grab any of the links that you might need from there. We've got the AIA sign up form, a free Acelab demo meeting link, as well as a link to go view Maximo's products on Acelab. So grab whatever you might need from there before we head out for the day. And if there's anything else you need, you can always reach out to our team at acelabusa.com. We've got a live chat there. We're here to support you. So please let us know if there's anything we can do to help out. All right, awesome. Lisa, thank you so much for an excellent presentation as always. Great to have you, and thank you so much for sharing all your knowledge with us.
Thank you so much. Thank you, everyone.
All right, thanks everyone. Have a good one.
Thanks.
Bye.
Bye.